Hello, it's been a long while. I'd like to share some exercises with us, which may be familiar, but I know will be beneficial. I've received a lot of questions and comments concerning these questions, and I would like you to pay attention as we go through them one after the other. This is a question that says, a body is positively charged means A, it is deficient of electrons. B, it contains only protons. C, it contains excess electrons. And D, it is deficient of neutrons. Let's start from option D. Option D, we should know that neutrons are neutral particles. Their excess or deficiency in the system do not really affect the charge. So D cannot be the answer. Let's move on to C. It contains excess electrons. When a body is containing excess electrons, since electrons are negatively charged, then we should expect that body to have a net negative charge. So the answer cannot be C. Let's move on to B. It contains only protons. Containing only protons, it's not feasible for us to have a body and say it contains only protons. It must have electrons as well. So B cannot be the right answer. Let's move on to A. It is deficient of electrons. When we have a body that is having equal number of protons and electrons, since the charge of an electron, it is the magnitude of the charge of an electron is equal to the magnitude of the charge of a proton. If a body is having equal number of protons and electrons, we can say the body is neutral, electrically neutral. So when a body is now deficient of electrons, it means it is having excess of protons. Hence, we can say the deficiency of electrons in a body implies that the body is positively charged. So for that, we go with option A. Let's move on. When a positively charged object is grounded, let's imagine the body. When we say it is positively charged, that means it has more of positive charges than negative charges. When a positively charged object is grounded, so when the body is grounded, what happens? Let's look at it also from the last option. Protons flow from the object to the ground. Yes, positively charged protons, will they flow to the ground? No. We have said that protons are heavier. They would not really participate in this electrical activity. Protons are heavier than electrons. They're about 1,800 times heavier than the electrons. So they would not like to move around. These the electrons that would like to move around. So we'll cross out option D. Electrons flow from the object to the ground. It is positively charged. It is having excess protons and deficiency of electrons. So we will not expect electrons to leave this body. So electrons will not flow from that object to the ground. Let's move to option B again. Option B is saying protons, excuse me, protons flow from the ground to the object. We will not expect protons to flow where there are electrons. So for that, protons flow, it's a no for me. From the ground to the object, no. Even if protons can flow, they will not want to flow to a positively charged object. But one, protons cannot flow. Two, they will not want to flow to an object that is already positively charged. And we are left with option A, which says electron flows from the ground to the object. Now let's look at it. This is having excess protons and deficiency, excess protons compared to the electrons. When electrons flow from the ground to the objects, then we can have equal number or almost equal number of electrons. More electrons will flow, and it will make the body to be more electrically neutral, to move the body closer to neutral. So when a positively charged object is grounded, electrons will flow from the ground into the body so that the net positive charges in the body will reduce. Hence, we can say that the correct answer here is A, which is that electrons will flow from the ground to the object. Let's move on. Which of the following statements is or are correct about the electric force of attraction or repulsion between two charges? This statement is when it is talking about the electric force of attraction or repulsion between two charges. The first thing that should come to our mind is Coulomb's law. And what is Coulomb's law? The first statement says that Coulomb's law states that the force of attraction or repulsion is directly proportional to the product of the magnitude of charges. Coulomb's law also says that the force of attraction is inversely proportional to the square of distance or separation. This is what Coulomb's law states. These are the two statements of Coulomb's law. Now let's look at the statement 1 we have here. Statement 1 is saying it is directly proportional to the product of the magnitude of the charges. Yes, that's good. I agree. Statement 2 is saying it is inversely proportional to the distance between the charges. This is not what Coulomb's law says. Coulomb's law says it is inversely proportional to the square of the distance. There should be a square of the distance. Hence, we cannot say that 2 is correct. Hence, you can say that the answer here is A, which is 1 only, because it is directly proportional to the product of the magnitude of the charges and not inversely proportional to the distance, but square of the distance. Let's move right. This is saying that the electron and proton of an hydrogen atom are separated by a distance 5.3. So the major point is that Q1, let's say Q1 be the charge of the electron, and that is equal to 1.6 times 10 raised to the power minus 19 coulomb. Though it's a negative charge, so I can decide to say minus 1.6 times 10 to the power minus 19 coulomb. Q2, let Q2 be the charge of the proton, and that will be plus 1.6 times 10 raised to the power minus 19 coulomb. Then the distance between them, R, is equal to 5.3 times 10 raised to the power minus 11 meter. So what is the magnitude of the electric force between the two particles? So since we are interested in the magnitude, we are no longer interested even in the sign, if it is positive or negative. We're interested just in the magnitude of the electric force. We're interested in the magnitude of either the force of attraction or repulsion. And that takes us back to Coulomb's law, which says that F is equal to K Q1 Q2, or divided by R squared. and that is equal to K. We can approximate K to be 9 times 10 raised to power 9 times Q1. We're interested in the magnitude, 1.6 times 10 raised to power minus 19 times Q2, 1.6 times 10 raised to power minus 19. Divided by the distance of separation, which is 5.3 times 10 raised to power minus 11, all squared. And when you punch in your calculator, you should expect an answer 8.2 times 10 raised to power minus 8 Newton. And that is option C. If you make a mistake by not putting a square here, if you make a mistake by not putting this square here, by not saying R square, you're most likely going to get an option. You're most likely going to get something, get option A. But the right answer here is option C. So all the options were calculated. There is no option that is redundant here. So let's move ahead. 4 identical resistors rated 3 ohms are used in a circuit. What is the total resistors in the circuit if the resistors are connected in parallel? In simple terms, 4 resistors. They are connected. There are 3 ohms, 3 ohms, 3 ohms, 3 ohms. They are connected in parallel. So the total resistance should be 1 over R equal to 1 over 3 plus 1 over 3 plus 1 over 3 plus 1 over 3. LCM 3, and 3 and 3, 1 times 1, 1 plus 1 plus 1 plus 1. And that will lead to saying 1 over R is equal to 4 over 3. And that means R over 1 will be equal to 3 over 4. That will mean R is equal to 3 over 4 is the same thing as 0.75. We can say 0.75 ohms rather. And that takes us to the third option we have here. So if you attempt to handle the 3 resistors as if they are in series, you would find yourself with option B. So just like I said, there is no redundant option there. So let's move ahead. Consider 3-point charges located at the corners of the right angle triangle as shown in the figure. Q1 equal to Q3. So Q1 is 6. Q1 is 6 microcoulomb. Q2 is -3 microcoulomb. Q3 is also 6 microcoulomb. And the distance of separation A is 0.1 meter. 0.1 meter. And the hypotenuse here is 0.1 √2 meter. So this is what we are asked to consider. And moving forward, find the resultant force exerted on Q2. Find the resultant force exerted on Q2. So the question is, what is F2? F2, resultant force exerted on Q2. That is equal to the force that Q1 is exerting on Q2, that is F12, plus the force that Q3 is exerting on Q2. So even without attempting to make any calculations, we can just solve this question straight away. Let's look at it again. The force exerted on Q2. This is Q2. Q3 is exerting a force on Q2, and the force is exerting is an attractive force in this direction. Q1 is also exerting a force on Q2, and the force is exerting is also an attractive force, attracting Q2 in this direction. So when looking at this diagram, we would expect the resultants of the two red lines to give us this green line. We would expect Q1 to move in this direction, the force exerted on Q2 to be the resultant of to be the resultant of the force that Q1 is exerting on Q2, and that's of which Q3 is exerting on Q2. Yes. The direction we have here shows that it will come towards the right, downwards. And this means that the direction is in a positive X direction and negative Y direction. So without even doing any calculation, the first thing to do is to check the options. And by checking the options, you would notice that it is only option D. It is only option D that agrees with that. It's only option D that has a resultant force that is showing a positive X and a negative Y. So if I were you, I would not take any further step in doing any calculation. But if you are the type that likes to calculate everything, then let's go ahead and calculate. And what are we calculating? We are calculating F12 and F32. So what is F12? F12 is equal to KQ1 Q2 divided by R12 squared times R12 caret. So when you substitute K with 9 times 10 raised to the power 9, and you substitute Q1 with, when you substitute Q1 with 6 microcoulomb, and you substitute Q2 with another 6 microcoulomb, then we should expect to have our expression to be of the form 9 times 10 raised to the power 9 times 6 times 10 raised to the power minus 6 times 6 times 10 raised to the power minus 6 divided by R squared. The R squared here is 0.1 root 2 all squared. And our R12 caret. So moving forward, I think I will need an eraser here. to move forward, we will now have our F12. Our F12 will be equal to 16.2 R12 Newtons. Similarly, our F32 will give us 16.2 R32 carats newtons. So the work that remains here is to determine what is R12 and what is R32. R12 and R32. R12 carat is equal to, it tells us the direction with which the force is being exerted. And when we look at this diagram again, R12 is the direction of the force, the direction with which Q1, the force of Q1 that is being exerted on Q2. And when you check the direction, it is pointing downwards. But the fact that it is pointing downwards, and we've labeled this to be x-axis, y-axis. But the fact that it's pointing downwards, then that means that is minus y. If you recall how you undo your graph book, this is minus y. So hence we can say that our R12 is equal to minus y. And our R32 is the direction with which the force the direction with which Q3 is exerting a force or exerting the force on Q2. And when you also look at the direction, it's in the positive x direction. So we can say that R32 carat is equal to plus x. And when we replace the R12 and R32 here with, when we replace the, let me move to the next slide. When we replace the R12 here with minus y and the R32 here with plus x, then we should have our F12 to be minus 16 y newtons. Let me change this color. Yellow is not a good color on every screen. Let's go back to red. And we can say that our F12 to be equal to 16.2, or rather minus 16.2 y newtons. So take note of the minus 16.2 y, and this to be 16.2 x newtons. So this the x and y are directions, so they are unit vectors. So, and adding F12 to F32 to give us F2, that will also give us option D, which is 16.2 x carat minus 16.2 y carat. So let's move ahead. The other question is saying, find the magnitude of the resultant force exerted on Q3. the magnitude of the resultant force exerted by Q3. So the force exerted by Q3, let's call it F3. So force exerted by Q3 will be the force exerted by Q3 on Q1 plus the force exerted by Q3 on Q2. Then we can now, checking this out, the next thing we should do is, what is F31 and what is F32? F31 should be K Q3 Q1 divided by R31 all squared and R31 caret. Similarly, F32 will be K Q3 Q2 over R32 squared times R32 caret. So we don't need to put all this here to save space. So when we solve this carefully, we should expect an answer of 16.2 R31 caret newtons. We should also expect for R32 a value of 16.2 R32 caret or newtons. So then the next question is, what is R31 and what is R32? Let's go back to the diagram. What is R31? Okay. R31 is number one, from F31 is telling us that charge Q3 is exerting a force on Q1. Then R31 will tell us what is the direction of that F31. So R31 caret is telling us what is the direction of the F31. And if we say Q3 is exerting a force on Q1, we would expect the direction to be in this manner. We'd expect the direction to be in this manner. And the manner of this, the sense of this arrow is telling us that that is a minus X and a minus Y direction. It's pointing in the direction of reducing X and reducing Y. So looking at that, for let's imagine a body, or imagine you to have moved from this point to this point, from Q3 to Q1. A way to describe that motion is to say you moved in this direction and you moved also in this direction. That is, you moved in minus X and you also moved in minus Y. And to resolve the unit vector, we have to say something like R31 of caret will be equal to minus AX, because the direction is minus, the length you traveled is minus A, and the length you traveled is A, and in the direction of minus X. And on coming down also, it's also minus AY. And the magnitude of the journey is, the magnitude of the distance traveled is the length here. And the length here is telling us that it has a magnitude of root 2A. Hence, we have to do some mathematical operation. A cancels A, and we'll be left with minus X caret minus y caret divided by root 2. And this is the real value of R31 caret. So when you attempt to find the magnitude of R31 caret, you should have 1. When you try to calculate the magnitude of R31 caret, the answer should be 1. So let's also try to calculate what is the value of R32 caret. I think we should have done something similar like to that before. R32 caret. R32 caret is equal. R32 caret is equal to saying that this is, you are in R3. R3 is exacting the force on R2. In what direction would that force be acted? This is R3. Sorry, this is Q3 and this is Q2. Q3 is exerting a force on Q2. And in what direction would we expect that force? It should be an attractive force because they are unlike charges. Because they are unlike charges, the direction will be in this manner. And this tells us that the direction of this arrow is a positive x direction. And without wasting our time, R32 is as good as plus x. So because the direction of the force that Q3 is exerting on Q2 is in the positive x direction. So we have R32 to be plus x. Thank you. So the next thing we have to do is to now add the F31 to F32. Then we will now calculate the magnitude. So let's move ahead. So F3, let me clear the screen. F3 which we said F3 is equal to F31 plus F32. F31 plus F32. And we have established our F31 to be equal to, we've established our F31 to be equal to 16.2 times R31 caret. And our R31 caret here is minus x minus y divided by root 2, all newtons. Our F32 is equal to, our F32 is also equal to 16.2 times R32. And our R32 here is x caret. And we are talking about x caret. Now we are interested in adding up F31 and F32. And by doing a careful addition, we should have our F3. Our F3 will be equal to 16.2 x caret minus 8.1 root 2 x caret minus 8.1 root 2 y caret, and all newtons. And going further, our F3 becomes 4.74 x caret minus 11.46 y caret, all newtons. When you find the magnitude of this, let's try to calculate the magnitude of this. The magnitude of F3 will be equal to saying square root of 4.74 squared plus 11.46 squared. And that will give us 12.40 Newton, which is option C. This should be a very long exercise. So let's move ahead. We still have another question under this group, and it's saying that find their electric potential energy. What is electric potential energy? Electric potential energy is mathematically defined as U to be equal to K Q1 Q2 divided by R12 plus Q1 Q3 divided by R13 plus Q2 Q3 divided by R23. And we know our K to be equal to 9 times 10 raised to the power 9. We know our Q1 to be 6 times 10 raised to the power minus 6. We know our Q to be minus 3. And we know the distance between R1 and R2 to be 0.1 meter. So let's remove the meter for now. Plus Q1 is still 6 microcoulomb times Q3. Q3 is also 6 microcoulomb divided by R13 is 0.1. The distance between R1 and R3 is 0.1 root 2 plus Q2, Q3. Q2 is minus 3, while Q3 is 6. And R23 is 0.1 meter. And you will recall that the microcoulomb were ignored all through this way, so that will be coming out, it will be 10 raised to the power minus 12. That is one. A microcoulomb means micro is 10 raised to the power minus 6. 10 raised to the power minus 6 times 10 raised to the power minus 6 is 10 raised to the power minus 12. And since we are talking about potential energy, the units will be joule. So if we calculate all this, just simple calculation from this point, we should have our electric potential energy to be minus 0.95 joule. Minus 0.95 joule. And you recall that in this calculation, we take into cognizance the magnitude of the charge. Wherever it is negative, we put the negative, and where the negative is useful in the calculation. If you ignore this negative signs, you will still find your answer within the options. But you are expected to know that this should be negative, this should be negative, and hence we should have a value of minus 0.95 joule, which corresponds to option B. So moving forward, use the information to answer questions 9 and 10. So this is so what is the value of I3? What is the value of I3? The first thing I would say from here is that I will start by quoting Kirchhoff's current law. I3 is equal to I1 plus I2. That's the first thing I would like to say. And thereafter, I would like to state some expressions. I would like to go through this loop in this direction. And going through the loop in this direction, I will say 15 volts is equal to, 15 volts. Going through R1, I will say minus 4I1 minus, and going through this 3 ohm resistor, I will also say minus 2I3. I've solved this in one of my previous videos, and that will be then equal to 0. So without wasting much time, I will also go through the second loop in this direction, and I'll start by saying 12 volts. After 12 volts, I'll going through R2. I2 goes through R2, then I'll say minus 3 ohms times I2. And the same I3 now going through R3, there will be a voltage drop there. Then I'll say minus. It should be I3 R3. Then since R3 is 2 ohms, that is 2 I3 equal to 0. So since I've solved this in a previous video, I should not waste time. The long and short is to say that solving, I'll come to replace I3 with I1 plus I2, and the I3 here with I1 plus I2, and it will now fall back to now obtaining I1 and I2 simultaneously. So when I obtain I1 and I2 simultaneously, I1 will be equal to 1.96 ampere, I2 will be equal to 1.62 ampere. Please go through my previous video. I've solved this before, so I don't want to waste time explaining all over again. Then I3 should now be equal to I1 plus I2, which is an addition of, which will be 3.58 ampere. And coming to the slide, 3.58 ampere is what we have in option B. And that is the answer. And when you look at the other options, you can see the value of I2 posing as option A, value of I1 posing as option C. And if you attempt to subtract them, I2 from I1, you should have option D. So you have to be very calm when answering questions. So, and finally, the last question on the board should be question 10. And question 10 is saying, what is the voltage drop across R2? What is the voltage drop across R2? We have established that I2 is equal to 1.62 ampere. Then V2, which is what I will call the voltage drop across R2, should be equal to I2, the current flowing through the resistor, R2 times R2, the resistance of R2. So that will give us 1.62 ampere times 3 ohms. And multiplying the two together should give us 4.86 volts. And that is the voltage drop across resistor R2. And without looking for too many things, we have that in option A. So I hope you find this video useful in your future encounter with electricity and magnetism. Best wishes.